Okay, so my talk is titled Automating Workflows with Deterministic Network of Modular Agents. It's a handful, but I hope that I can explain the concept over the next 20 minutes. My name is Millin. I'm the co-founder and CEO of Keyflow. And at Keyflow, we help businesses and enterprises automate work with AI agents. So today's agenda is a little bit tight. What I want to do is go over the background of evolution of AI systems and do a quick level set on what agents are and what people are thinking today. Then I'll talk about what we tried to do and the problems we faced over the last 6 months and how we solved those problems and some customer results, as well as takeaways and design principles that we have learned while building automations with AI agents. So quick start, evolution of AI system, we can quickly bucket it into 3 different stages. First was deterministic flows. So this is when ChatGPT just had LLM, we just had LLM APIs and we could give text in and get text out. This was 2020 to 2022 era, right before ChatGPT. And people were building these LLM-based deterministic workflows where they were just using intelligence in the process wherever they needed. Then we had LLM with tool calls around March of 2023, 2024, where GPT-4 first came out and they had ChatGPT plugins, and people started thinking about giving LLMs access to retrieval, memory, as well as function calling, and this allowed LLMs to actually take actions for the first time. And people were using LLM with tool calls, just playing around with it and putting in their deterministic systems that they had built before. But then reasoning models came about, and we had agent loops. That's what you see a lot of action in the product today. And this is where we give LLM a goal. And instead of defining the processes ourselves, we let the LLM define the process by interacting with an environment and taking the feedback and looping itself to accomplish the task. There are a lot of different ways people have tried this early on last year as well. It didn't really work, but reasoning models really changed the game here. So let's quickly go over flows versus loops. So we also have a level set on this. So flows are where humans plan the systems. Loops are where LLM plans the execution steps. The process for flows is very rigid. Loops are very dynamic. They are more general. And there's a trade-off that flows give you more control. So it's really nice for deterministic solutions. But loops give you agency, so you can build something that's very generic. And the promise of AGI is most likely something that people feel that it will be accomplished by the loops. Then we have I just wanted to show some example of flows versus loops so people can calibrate on it. So flows is a data augmentation pipeline where you would have customer support call data and you would want to extract sentiment or extract frustrations or pain points of customer. And you would create a deterministic flow for that. Versus a loop is a ChatGPT o3. If anyone has used that recently, it has web browsing, code interpretation, and as well as image analysis. So you could give it an image of any place on Earth, and you could ask, where is this from? And it would use all these different tools to analyze and figure out the solution. Or you could give it a PDF, and you could ask it to do analysis, and that's where the more agency part comes in. So LLMs can kind of run in a loop here and figure out the solution. Then there's this other concept that I want to also level set on, which is chat agents versus ambient agents. Ambient agents, if you haven't heard of them before, it's just a fancy way of saying long-running background agents. So in chat agents, it's a synchronous conversation. You have multi-turn conversations with a person. They are both sitting at the same time doing back and forth, so multi-turn. And with ambient agents, it's asynchronous. There's long-running background tasks that are happening behind the scenes, and there's usually no person involved. There might be interrupts where they would stop the flow and ask a human for feedback, but that's very different than being asynchronous flow. This is more how teammates work, where they are working on their own things and they collaborate during meetings. The chat agents are triggered by user messages. The background agents are triggered by cron schedules or events that happen like when you get an email, when you receive a Slack message, etc. And in terms of concurrency, with chat agents, you can only have 1 to maybe max 5 windows that you can work with at the same time, versus ambient agents can run as many as you want in the background, and there's really no limit. It's how much compute you have is the limit. In terms of latency, chat agents requires very low latency for good user experience. There is no specific requirements for ambient agents as of now because they do work in background. Good example here is Cursor and V0 are good chat agents where you are using them to code and you are in the loop while they're doing work. Maybe you're sitting a little bit, taking a sip of coffee while it's working, but that's how these systems work. And good ambient agents are deep research that's been very popular made by Gemini, but now OpenAI and Claude both have it. Codex that OpenAI recently came out with that can fix bugs for you and you can run multiple of them in the background. And then there's also code review bots that a lot of startups or YC startups have been doing recently. The interface is one of the most interesting parts for ambient agents for me, because chat agents, there is a clear winner, which is chatbots. But there's no clear winner of what the interaction pattern of a person with this ambient agent would be. It could be some sort of action center where you wake up in the morning and you sit down and you see all the tasks that the agent's waiting on you for, and you just give your feedback and clear that inbox of actions that you have pending. And this could be a very new paradigm of how things are work. Another interface that I think that's very important for ambient agents is observability or monitoring platform, where how do we know what the work is being done and how can we verify the work? So to build trust, it is very important that we create some sort of observability or monitoring system of how these agents are running in background. So for automation, of course, it makes a lot of sense that we would focus a lot on ambient agents instead of chat, because with chat, we expect a person to be in the loop of the conversation, but with ambient agents, we don't. So we wanted to build out ambient agents about 4 months ago for some of the customers we had at Keyflow, and Keyflow was doing LLM-based automation before that. So here's some things that we did. So our vision was very simple. We'll take what works for chat, which is reasoning models in agent loops, and we'll connect them to MCP servers, right? There are so many of them available out of the box, and we wouldn't have to build integrations from scratch. And we would be able to quickly experiment and iterate on how these processes would look. And we thought we had discovered a gold mine. We had infinite number of automations we could make. The system works really well. And this is the diagram that we had. This is a simple React agent, but we had multiple different types of LLM loops that we were experimenting with. So we had reason, act via tools. The tools are coming from the MCP servers. And then there's reflect step, and it does it in a loop. And I want to show you, there's a lot of hype about AI coding, but it's also real. We don't use it for production code, but I did build this app in 4 days using a coding agent. So I have agent, tools, and MCPs as different tabs here. Tools are tools that we write as Python function, and we can bring it and we can test it very quickly. MCPs, I can connect an MCP to a URL very easily, and I can bring those MCPs here. I can see the tools that each MCP server has that I can give access to my agent. And then when I go to the agent tab, I can select the architecture of the agent that I want, and these are all written in our code base. We can set the system instructions. We can set the MCP server here. We can say we want to give access to Notion as well as Gmail, or we want to select calculator tool or web search tool. And we can select max iterations, and all these different processes just allow us to experiment with different models, different hyperparameter tuning for, when you're doing traditional machine learning training. This is kind of like those hyperparameters for agent not training, but agent optimization. And here's the results of what a run looks like. I'll come back to this later, but just wanted to quickly showcase our vision and how we kind of approached this problem initially. But this didn't work. So we had a lot of issues, and I want to talk about some of the issues we faced and how we solved them. So the first issue we had was hallucination spiral. In conversational agents, I talked about before, or chat agents, you have this user message. Maybe there are a few tool calls, and then the control comes back to you, which means you can steer the agent and there's very less user dissatisfaction if the chat agent or chatbot agent is done or built really well. Because it would interact with the user and it would ask clarifying questions until the user has bought into what they want to do from the agent. But with background agents, there is no feedback, and it needs to run for a very, very long time. And I think all engineers can see why this is a big issue. There is all these different calls, and there's a high chance of the agent deviating or hallucinating because it's just compounding every tool call after tool call. The second thing that we encountered was that MCP tools that we were hoping that we would just get ready-made integrations, they didn't really work that well. The reason is most of the tools are API wrappers. And this is not very helpful to the agent itself, which is a reasoning model. If a reasoning model has to label 30 emails and it's going to label it one by one because it has to follow the process of it only has access to label one email at a time, it's going to spend a lot of tokens, it's going to spend a lot of cycles doing wasting compute. And when we started really thinking deeply about it, like what does the agent see from its sandbox, we should probably create really high-level tools. High-level tools that make sense for agent, where the input is in English, the output is in English, and agent can kind of just work with those tools very easily. And the complex part of how the batching of the labels or the sending of the emails is done inside the tools. So here you can see that I'm taking the concept of deterministic flows, putting that inside the tools, and now giving it access to agent. And my number of tools significantly reduced. I was able to create one input, one output system. So the query or whatever the input is always is in English, plain English, and I can extract or break down the query within the tool, do the API call, and do a very high level processing of the agent itself. So that was the problem, and that's how we solved it. Then even after solving and making tools high level, another thing that we quickly encountered was context explosion. So our stack pretty much looked like this for context windows. A lot of the percentage was occupied by the tool results. And tool results, the reason it occupied a lot of percentage is because APIs still respond in a way for deterministic systems. They're created so we can do a lot with it when we're building deterministic systems. But LLMs don't work like that. So here you can see a raw JSON. If you just dump that into LLM, it's going to have 1,000+ tokens for a simple email. But if you convert it into YAML and extract the email body out instead of the HTML, it's going to be much more cleaner for the LLM, and the number of context size also goes down. And then in the stack itself, the system prompt takes a lot of percentage and less hallucinations happen. So all these problems that we were encountering, we were solving it one by one, but they're compounding. One problem solved compounds the value of the other problem that we encountered, and that once we solved that, both high-level tools as well as context cleaning after context engineering is what we are calling it, that helped us a lot when it came to building this valuable agents. Even after we did all these things, we created high-level tools, we encountered tool explosion problem. So not only we want Gmail access, we want to give our agents all the access possible. And there's never going to be a limit on the number of tools you want to give access to. So how do we solve this problem? Because the number of tools are going to keep increasing, and the good number of tool set today is 20 to 25 tools. So what we do is we would break down these agents, we would create different modular agents, and this is where the title of the talk, Deterministic Network of Modular Agents, and we'll get to the deterministic network part in a second. So right now we're focusing on the modular agents. We're going to give an agent a scope, and we're going to give it tools. And I think a lot of talks today have talked about agent orchestration, and this is sort of leading to that. So we discovered that we had to do agent orchestration, and we had to probably create our own framework or use out-of-the-box framework. But the problem was we wanted to try all these frameworks, and there were a lot of them. We didn't know which one was good or which one was bad, but what we thought was we should have some sort of interoperability where we could create one modular agent in LangGraph, other using OpenAI SDK, and they could talk to each other. And that would allow us to use the best framework for the best agent, and we would be able to create the best systems. So we solved this problem by building our platform, which I'll also showcase in a second. But this was something that we encountered where there's new frameworks are going to come out, so we should probably be agnostic to framework, and we should allow all frameworks to work within our system. And the final thing was deployment infrastructure. So after we solved all these problems and built the agents and put it in production, we realized that ambient agents have different problems than chat agents. Ambient agents are bursty, as in you could get a lot of emails at once, and a lot of instances of this agent would have to spin up right away. They could be flaky because they're running for a very long time, and there are a lot of chances for API failures, and you really need to create invincible systems. So we actually created a mini agent that can self-correct when it's running things in batch. If it's trying to label 25 emails at once, and if one of the it reaches timeout, or if it reaches rate limit, it can exponentially back off or retry based on its own internal LLM module that we had embedded in it. And we solved all these problems for creating a generic system that could work for any action. And now we have this successful batch action agent that can take any API and make sure it's successful. And one of the good things about why we are doing this is we don't really need to worry about latency, as I mentioned before. So even if it takes a little bit more time or agent goes to sleep in between, it doesn't really matter because the agent's running in the background and people are not occupied while the agent is running. The long-running part, of course, we had to create background jobs and had to create a system where we could pull the process of the agent. We had to create the streaming system, so there was a lot to solve in that area as well. So now I want to do a live demo and showcase what the deterministic network of modular agent looks like. So here's the platform. It's a canvas, and we have designed it so anyone who doesn't even have engineering background or capabilities, if they just know how to use English and if they understand systems or just graphs, they should be able to create something. So here you can add any block that you want. Let's go ahead and add a Gmail agent block. So this agent has access to my Gmail tools, right? And I can give it a specific action to make the action more deterministic because I'm talking about determinism in a long-running process. So we can define the agent and say, okay, you need to search emails. And now I can say, can you get all my unread emails from last 7 days? And now it has this prompt, and that's all I need. And now I can run this agent, and it's going to show me the logs that it's running. Let's see here. So now the agent's running. I can see that it's processing these queries. It's trying to find it, and it didn't find any emails that are unread. Okay, so Android. That makes a lot of sense. I guess speech to text is not that great. But so it's going to run in the background. It's going to do all its thing. And while it's running, we can also configure it to do something else. So it's going to give me a list of emails, right? And I can take it and I can add categorization to it. So I can say, I want to categorize this email, but I want to do one email at a time. So I'm going to turn on batch. And I'm going to say, we'll connect this. And I want to loop emails. And I want to take each item here. And I want to add category. To archive, to delete, and simply just doing that, I could create an agent, and I have it here because I knew that I would mess up the live demo somehow. But let's go ahead and look at this, and here I have this: assign a corresponding label to this email. I give the email, and I just give English instructions on what it needs to do. And finally, I'll say, take all the emails and just here are the emails, here are the labels, and apply the labels based on the list. And here we can run this, and it's going to run in the background. And I want to show you here, there is no emails labeled except for to reply. But after it's run, it's going to label some of my unread emails from this 481. And hopefully we can come back to it while I'm demoing other things, and it's going to run in the background right now. So here's a previous run that I did, and this is the monitoring thing that I was talking about. When we are running agents, we want to know what work they're doing, and we can quickly go and see what emails it returned as outputs and what were the inputs to the block. So my input was simply a prompt. The output emails were here, and I can see the categorization of each email, and I can see the inputs. So inputs were this list of emails. Output was, I can even see the cost per run, per categorization, which model it used. And here's the label. It says to archive, to reply, interesting read. So number 0 is labeled as to archive, and I can see it, and the email itself is here. So it's a marketing email and said you need to archive that, and I can then slowly, once it's in production, I can then slowly see the type of labeling it's doing, and I can improve the prompts, and I can do the optimization loop for improving my agent after. Here's another example. After my agent labels something to reply, this agent can pick off the task of the first agent and now draft a reply for the emails it has labeled as to reply. And here what it's doing is it's going to say, only grab emails that are labeled to reply. You want to extract the name of the person. And for each person, you want to go into the CRM that we have listed in Notion, and you want to find the memory around this person. And then you want to draft a reply for the person based on the memory. And then you want to apply the label that I've generated, reply has been generated. And this agent, I ran it yesterday, worked, but it takes a while. So we can see there were some failures when I was trying to build it out, but once it ran, I was able to, it takes about a minute to run. And here I can see the results of, there was one email that it tried to label, try to generate a reply for, because there was only one email in the to reply folder. Then this is another workflow that has actually been very good for generating revenue for our own company. And we're calling it proactive customer success. So when people come to our platform, this platform, and they try to build something, there's a high chance they're gonna not build it at the first try. So what we did was we put an AI agent on our database, and we built this modular network of agents to kind of find information on what is the person trying to do, format the data, analyze what this person was trying to do here, and create an HTML report and send it to me. And I want to showcase that report. Hopefully I can find it here. But the entire report that it generated was created by, let's see here. So this was the weekly flow report. This entire report is generated by our workflow. So I can see the user, I can see what they were trying to do, and the suggestions on how I can reach out to them. And this entire process is so arduous for me to even think about, of me going and doing data analytics. But every morning I just get this report of the 5 or 7 users who have had issues with my product. I can just reach out to them. And this is what we really want to enable for businesses, where there's a lot of arduous manual work that you would never even do if agents didn't exist in the world. And we want to automate those things, not the things that people do today. Human feedback is very valuable. We think is one of the best things for agentic systems. But these kind of ideas where you can have a direct line to revenue is what's most important. And this custom agent that we wrote, so anyone can write any agent in any library using TypeScript or Python, and it's a simple agent here. And if you wrap it in a block with our SDK, you can bring it in as a custom block like this. So here's our server that's running, that's connected to this custom agent. You can fully deploy your agents on your own cloud, and you can just orchestrate them on our platform. So the benefit of this orchestration is that not only your engineering team can have access and play around with these agents, everyone in the company can have access and play around with these agents, which makes the number of iterations go fast, and the flywheel of agentic automations within the company increases significantly. So that was deterministic network of modular agents. What I want to do quickly now is talk about some of the results that we have seen. We saw 90% step reduction. Step is the agent steps that happen because we created high-level tools, because we created different modular agents. We were able to specialize tools as well as the agents on very specific tasks, and we were able to reduce the number of steps that usually agents have to do over and over again by 90%. Oops, I think I went back a little bit here. We saw 30 to 75%, so task completion rate was 30% with normal agent loops. With our deterministic network of modular agents, it was 75%. And we also saw a huge amount of token reduction because of our context engineering solutions that we built in. Customer results for a consulting firm, we built RFP Hunter. So it would go to different RFP websites, it would find and it would put them in the spreadsheet. Then people would review the qualified RFPs, and they would select the ones that they would want to write proposal or create a positioning for. And then finally, once the proposal positioning has been provided in a feedback, the last agent can pick up and create drafts from it. And this company this agent, like the Hunter specifically, has processed over 10,000 RFPs. Over 1,000 proposals have been created a positioning against, and there has been hundred thousands of hours plus saved because people were really spending entire days on just kind of positioning their company for this RFP proposal they were writing for. We help them do 80-90% of the work by deploying this background agents that collaborate with the people. Another success story so once we had a success story with our customer success internal agent, we did it with a financial startup that's Series B, and they were able to actually retain $1.5 million worth of revenue because and we calculated it using the churn. So we reduced the churn, and those customers that were going to churn, or the churn rate that we did reduce to, correlated to this revenue right away. And it processed 50,000 plus customer interactions in their system. So the key takeaways here are there are good and bad ways to do automations that we have found. And good automations are the ones that increases revenue, frees up time from routine manual work, surfaces insights, and lets you do things you would never get around to because of friction. And bad automations are the ones that make people complacent and lowers the quality of output. And maybe they burn a lot of compute, or they reduce the product, service, or quality. And this is where it's very important for us to work closely with the partners that we work with to identify the business goals and make sure that the agents that we work with are actually solving the real problems, and the human agent collaboration system that we want to create is productive and not deteriorating to the company's output. Of course, we highly recommend everyone, even if you use Keyflow or not, to build modular agents. It's going to help a lot. Everyone has talked about orchestration is the next big thing. So highly recommend that. Another value that we have had, or we have seen with our customers, is they have been able to give access to tools to everyone. As I mentioned, when you give access to everyone, the flywheel just kicks off faster. So one of the key takeaways that we have learned is involve everyone you can in the agent building process. And give them tools. Monitoring over evals is another concept that I have internalized. I used to worry a lot about writing the perfect eval set. And now what we have done is, instead of that, we cut off the agent from taking actions that could actually be consequential. And we would just make read-only agents and start them. So here, a read-only agent is agent that's looking at my emails and just drafting, labeling them. I'm not going to send the emails out until I'm very confident on the system that I've optimized until. So once I've optimized the system, then I'll bring in the automation at the end state. And here's what run looks like. I showed you before, so we'll just skip past that. When we're building agent loops, it's great to have self-verification. So for the database agents, what we do is we have an environment, we run the code against it, and if the SQL query fails, we would pass the results as well and run that in a loop. Unless there's a self-verification system for agent to self-improve, loops haven't been that useful, especially for background agents. Maybe for chat agents, they could work, but we haven't found any success with that. And then including human feedback. As I mentioned before, human feedback is not only valuable because you can collect the data set and improve the systems later. It's also one of the critical parts because it will help agent self-improve and build memory over time. So anytime, if there's no human feedback, the system is just going to do what it's doing over and over again, versus when there is feedback, that signal of thumbs up, thumbs down can really help the company optimize their systems over time later. We are opening up early access to our platform. This is the new canvas that's coming out right now. If you go to our website, it's the old automation platform. It still works, but there's no agents in there. That's the catch. We have 100 plus pre-built agent blocks that are going to come out. And this is mostly for people who are interested in building and getting their hands dirty with the agents. You can one-click deploy your flows that you build, the deterministic flows as MCP, APIs, schedule, you can trigger them on schedule or event triggers. And there's built-in observability and monitoring, there's memory, human in the loop support, and of course, orchestrating agents from any framework. And for more of executive leaders, this is the collaborative partnership that we do with companies. We understand your business goals, we discover opportunities for ambient automations. Then we design the agent-human handover system, and what's the best UX. We design that quickly as well. We'll develop the custom modules using our block servers if we have to. We'll co-create agents. So once we have all these things ready, we'll just give access to your team of the platform, and they can play around with it and start deploying the systems in a very secure manner. And then at the end, we assist with the monitoring and improvement of agents over time as well. So that's everything. Yeah, thank you.
Hi. Thanks for the interesting and timely talk. I'm just still trying to understand how would you differentiate yourself from Microsoft's semantic kernel, LangChain. You did mention you can use all these frameworks,
Yeah.
but even they allow you to build modular agents, have determinism within them,
Right.
And how you're trying to differentiate yourself. Thank you.
Right now we're not, because we aren't trying to work with everyone. The thing is, building agents is hard. So everyone's building platforms, but even after people have access to platforms, the close collaboration is where people are really seeing values. Even big companies, I think IBM yesterday also mentioned they have their builder workshops, and that's where people are seeing values. So for us, how we are differentiating ourselves is, first of all, our UX and making it really product intuitive, because every product that's built today is built for automation-minded people. And what we want to change that is we want to allow even anyone in sales who has never done automation before be able to come into our system and simply type English and it just works out of the box. So that part is really hard, and we're working very hard to push out this new system, and that's why there's the early access link, and it's not available to everyone yet, and it's only available to selected people. But we are really trying to push that boundary forward of the number of people who can actually do agent engineering.
So you haven't mentioned this explicitly, but I wonder if you're putting into the fold also some bias detection mechanism. As long as you're just creating agents for downloading some information from here and there, I'm okay. But if you're drafting emails or processing information that can, I don't know, relate to people, I think it's important to be mindful of possible hiccups of this sort.
That's why we draft emails and not send them, right? So that's one of the things where we really believe in not letting agents expose to customers, and it should be for internal use only, mostly. Yeah. Thank you.